Good morning, sir.
Yeah. So tell me, what is the universal quantifier? One is universal quantification, another one is existential quantification. So what is said to be that is universal quantifier?
So P of x for all values of x in the domain is
Yeah,
true.
P of x for all values of that means for all x P of x, that is the quantification. That is universal quantification for all x P of x, where P of x is the predicate. What is universal quantifier? Universal quantifier, that symbol for all, for every, for each. These all are universal quantifier. When applying universal quantifier to a variable x, then a predicate P of x, that becomes universal quantification. So for all, that is the universal quantifier. Okay. The universal quantifier for all x P of x, when it will be true and when it will be false. That is the basic thing. Just raise your hand, want to say. When universal quantification for all x P of x, where P of x is any predicate, when it will be true and when it will be false.
So for all the values of x are in the domain and all are true, then the quantification is universal. And if any,
Universal quantification, that is true. Okay. Then when it will be
yes, sir.
false?
If
When all
any one of
values
the
are
is true, then is false, then it is not in.
Yeah. That means when you are checking if the predicate P of x is true for all values of x that are present in the given domain. Domain is the set of values of x. Then that is universal quantification will be true. And when it will be false, if the given predicate P of x is false for at least one value of x that is present in the domain. That means if you are finding a point x that is present in the domain, but for that particular value, the given predicate P of x is false, then you can say that the universal quantification for all x P of x, that is false. Okay. Then one more thing, if the domain contains finite number of elements, let x1, x2 up to xn, then for universal quantification is equivalent to what? For all x P of x, that is equivalent to P of x1 conjunction P of x2 conjunction up to P of xn. That is also one of the formula. That means when a domain contains finite number of elements such as x1 to x2 up to xn, then the whole universal quantification for all x Px, that is equivalent to P of x1 conjunction, all are n will be P of conjunctions of P of x1, P of x2 up to P of xn. Okay. That is all about universal quantification. Today we will see about existential quantification. Okay. two types of quantification. In the last class, we have discussed all about that universal quantification. Another quantification is existential quantification. Or you can say existential quantifiers. The existential quantification always of a predicate P of X with the statement or proposition. What is that proposition? That proposition is there exists there exists an element in the domain.
It games set in a virtual world and does not represent real life. Please play in moderation. Take frequent breaks.
Also mute yourself.
I got supplies. I got some.
Yeah, that means see this statement. So existential quantification of POS, that is the exact meaning is there exists an element in the domain such that P of X. That means see some elements are given in the domain. If you are finding at least one element in the domain such that the given predicate is true, then that is called the existential quantification of P of X. The existential means there exists at least one. There exists an element. Okay. We use the notation for all symbol, for all, that is for universal, there exists, that is for existential. The symbol is there exists X, P of X. P of X is the predicate. This notation is for existential quantification for the predicate P of X. You can read this. There exists a P of X or identification of the predicate P of X. Here, there exists symbol. This symbol there exists. What is this? For all symbol. That is the universal quantifier. So what will be this symbol? That will be similar existential quantifier. Existential quantifier. See, for all, the symbol or follow what? That is the universal quantifier. There exists, that is existential quantifier. For all x px, that is universal quantification. And there exists x p of x, that is existential quantification. Okay. Now we'll see this existential quantification when it will be true and when it will be false. Existential quantification, that is general standard notation is there exists x p of x is true. Then tell me when it will be true. Definition is there exists an element in the domain such that p of x. Then tell me there exists a p of x when it will be true. That means it will be true if and only if the given predicate p of x is true for at least one value of x in the domain. That means if there are infinite number of elements in the domain or finite number of elements in the domain, if you are getting at least one element in the domain such that the given predicate is true, then you can say that there exists x px is true. Then when it will be false? When
X is false for every element.
no, it will be false. There exists will be false. That means there exist no elements in the domain so that the given predicate is true. Then you can say that there exists x px, that will be false. That means if there exists no such elements in the domain, for which the given predicate is true, then we can say that the existential quantification there exists x p of x is false. That means there exists means there more, if it will be, that will be true if you are getting at least one element present in the domain such that the given predicate will be true. If there exists, if you are not getting a single element in the domain so that the given predicate is true, then only you can say that there exists x px, that is the existential quantification will be false. Let p of x, that is the predicate that is given, x greater than 15. That is the given. What is the truth value of quantification? There exists x p of x.
Sir, can you please write more properly so that we can read it in future?
Means what about?
Sir, your handwriting, sir.
Okay. See, that is the class notes. Okay. After that, I am sending the fair notes. You can go through that.
Okay, sir.
The given predicate is
Sir.
p of, yeah. Sorry.
Sir, the last class we saw the examples of universal quantifiers.
Yeah.
So all the examples we did in the last class, all are existential quantifiers.
No, no.
The ones which are false.
Tell me who is example?
So in the last class we did example 1, p of x be the statement x plus 1 greater than x.
Okay, x plus 1 greater than x.
Yes.
So you have to check that if that is the p of x predicate. If that predicate is true for all values of x, that is x are real numbers. So you can
Yes,
say
sir.
that if you are taking any real number, so x plus 1 will be greater than x. So it is true for all x. So the universal.
Sorry, sir, not that one.
Okay.
So the statement x less than 10 and the
Okay.
domain is real numbers.
Okay, see, x less than 10, domain is real numbers. That means if x less than 10 will satisfy for all x that present in the domain. So domain is real numbers. The real number contains infinite number of values. So if you take x equal to 11, 12, 13, 14, that are not less than 10, that means there exists an element in the domain so that the given predicate p of x is false. So the universal quantification will be false.
So but the existential quantification will be true for this.
Yeah, yes, yes. In that case, existential quantification will be true. Definitely.
Okay.
Yeah. You can take that example also. See, that is x greater than 15. You can take also x less than 15, whatever the example. So x greater than 15. That I am taking the example. So domain consists of all real numbers. Then tell me, this existential quantification will be true or false?
True.
True.
Because just see,
True.
just you have to find if there exists a element x present in the domain so that the given predicate is true, then we can say that the whole quantification or their existential quantification, there exists x p of x will be true. If you are not getting any element, no element is there such that p of x is true, then only you can say that that will be false. That means that is very simple. You can check any example. X greater than 15. So take a example which is true. Let x equal to 16. P of, I'm taking the 16. What will be this? 16 greater than 15. That is true. So it is true. That means you are getting a element x equal to 16 which is present in the domain. Also that satisfies P of x is true. So the existential quantification, that is there exists x p of x is true. Here domain is all real numbers, so that it is true. Okay. If the domain contains 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then this existential quantification will be true or false?
False.
False.
Because if the domain contains only elements from 1 to 10, so if you check 1 greater than 15, that is false. So all the elements present in the domain, for that, that means you are not getting a element present in the domain so that the given predicate is true. In that case, you can tell that the existential quantification will be false. So that depends upon the domain. Domain is very important. So always observe the domain. Okay. For each, like this, instead of there exist, we can also use some other words like this. Besides, there exist. We can use we can use some other
Bounded set.
bound. But here, what is the scope of the quantifier? So you have to observe in this statement how many quantifiers are there.
2.
2 quantifiers are there. It contains there exist quantifier also for all quantifier. So in this universal quantifier also as well as existential quantifier. So we have to find individual scope of the quantifier. That means in this example, the scope of the first quantifier, that is there exists x. What will be this? What is the scope of the quantifier? There exists x applied to what?
So
Applied
P
to
of x and
P of
Q
x
of x.
and Q of x. That will be P of x and Q of x. This expression is the scope of the quantifier, existential quantifier. Similarly, why it is there exists x applied to this expression only. That means why h there exists x is only applied to P of x and Q of x. Similarly, the scope of the second quantifier, that is for all x. What will be this?
R of x.
Is R of x. That means there are 2 scope of the quantifiers. for universal quantifier for all x, scope is R of x. The scope of existential quantifier here in this statement, that is P of x and R of x. Here x is also bound. Variable x is bound. If it is also for all y R of x, here also y is also bound. If you are writing y for all y R of y, so y will be also bound. So this given statement, this can be written as in the other words. That means, see here the existential quantifier, that is there exists, binds the variable x in the expression, that is P of x and Q of x, and the universal quantification for all x binds the variable x, that is in the expression R of x. So as the scope of two quantifiers do not overlap to each other, so that means you can see as the scope of the two quantifiers do not overlap, then the given statement can be written using two different variables. X and y. What is that? See, you can write it the same expression. There exists x, P of x and Q of x. You can use for all y R of y. Okay. I just use the disjunction. Okay, we'll see that is maybe disjunction is used in this case. Okay, I'll check it. Disjunction for all y R of y. That means, see, when there are two independent variable x and y, so there exists x that only apply to P of x and Q of x. But again, another quantifier for all x that is only applied to R of x. So you can, in that case, you can use also two variable x and y. That means here you can check that x and y, both variables are bound. No one is free here. Okay, we'll stop here. There are also logical equivalences using quantification or quantifier. We'll see in the next class. Okay, just wait.